start talking.
Okay. Hello everyone, we are group 9 and today we're going to talk about chaos engineering. We're going to start by talking about what exactly is chaos engineering and more or less its impact. As distributed software is becoming more and more complex and being so important in our society, developers often focus on its flexibility and the speed being deployed. However, can we trust on the system? Is this system trustable enough? Are we certain that this system will survive any problems that may arise during deployment, for example? Even if the system is theoretically working as intended and all the inner parts are tested, we must consider that sometimes these systems may use services which may not be available, or they can produce different errors, or their normal execution of them is not working as intended, can have integrity problems. Thus, we could say that there are many unpredictable conditions that might affect our system's availability. So, how can we test that our app can withstand these problems? Chaos engineering is the discipline that tries different solutions, different experiments within a system to make it more trustable regarding the possible outcomes that may happen in production, dealing with operations like failure injection testing and overall ensuring that it does not affect the entire system. This, of course, changes greatly the way systems are designed, since they will focus on a system that might not always be in a steady state, like some of the services it relies on are unavailable, as we already said, or connection fails. This provides a way to assure that our system is very reliable and can recover from errors and overall maximizes its availability. Now we're going to talk about some history about it. From a monkey to a discipline. It all started in 2010 when Netflix, as you all know, the streaming service, surprised the world with Chaos Monkey. This was a tool that tore apart one of the servers where the system was deployed, where Netflix was deployed. The premise of this was simple. Errors are bound to happen, in this case, a server failure. And so it is best for them to happen when they want, since they will be ready to tackle them. This was a very useful feature overall, since when those errors unexpectedly happen, it would not be that troublesome, since the system already expected them. 1 year later, in 2011, Chaos Monkey became part of a set of tools, a project called Simian Army, which then disevolved into ChaosCon. This tool not only took down a server, but a complete region, a complete Amazon Web Service region. Even if this error hardly ever happens, it has happened. Actually, on September 2015, to the 28th, Amazon's DynamoDB service was unavailable for a period of time, 8 hours, I think, making the system that relied on them unavailable too. However, Netflix only just suffered a bit of availability loss, since they quickly identified the error and sent a fix to it, thanks to all the testing and preparation this tool, ChaosCon, provided to them. So thanks to ChaosCon and by running this kind of error experiments very regularly, they had a strong system which could handle this region failover. And how can they analyze if the system is becoming more resilient? They provide an example on their web. In the first chart, you can see the combined view of systems. The chart global, then you have the use west and the use east, while the lower ones show the different metrics of each of the labeled regions. As we can see, even if the traffic lowers in the west graph, this is backed up by the east server, and thus the combined view, the global view of the chart, does not have any peaks, almost as if nothing happened. Going one step further, they wanted ChaosCon to evolve by looking at other engineering practices, finding out that chaos did not have a really universal meaning on them. Thus, they proposed to create a definition, a best practice definition, something that could be applied to any of the projects and that it would make their services more trustable.
However, they didn't want to remove the complexity of their system.
They wanted to have a resilient system if it was very difficult, or they have some other important focus such as flexibility or rapid development. With this premise, a new discipline called chaos engineering was created. This was an empirical system-based approach that assumes, as already explained, that chaos was going to happen in the systems for sure. Thus, we should be able to build a system that has enough capabilities to withstand these conditions. To finish with this part, we can see the clear evolution that chaos tool has happened. First of all, the Chaos Monkey tool, which Netflix first created just to make the system more trustable, evolved into a more complex and more intensive tool named ChaosCon, to later be transformed into a full discipline that can uncover weaknesses before they even happen. I'm sure that you are thinking about what are the steps to accomplish this discipline. As I can see in the diagram, there are 4. To apply the theoretical concepts that have been presented until now, that 4 different and clearly defined moves need to be followed. The first one is to describe what is a steady state. That is, when a system reflects a normal behavior, it means that working as expected. The second step is to make a hypothesis stating that the previous situation will remain in 2 different groups, control and a challenge group. The third is to establish stress variables in the challenge group of the second step, as it will suffer different failures like server failures or hardware issues. And the fourth one, but not least, is an attempt to invalidate the hypothesis developed in step 2 by showing differences between both groups. Well, after executing the actual experiment, the result can be positive or negative. If it is positive, we confirm that the system is already resilient to the injected failure. But if a weak point comes to light, like the results are negative, there's no problem. A new target for improvement appears, so it is tried to be fixed before it is too late. When talking about what experiments could be run, and consequently the real factors to be tested, a problem arises, and it's in relation with forgetting some possibilities to not be aware of them, for example. We intend to solve this, so there are predefined order of experiments to be performed, so these situations could be minimized. And as you can see in the diagram, there are 4 different types of experiments that are a combination of the others, more or less. Their names are very useful to have a first right understanding of their meaning. The first one is known unknowns. That is testing for elements that we are aware and we understand. The second, known unknowns, that are experimenting for things we know, but we don't have a clearly comprehension of them. The third, known knowns, is checking events that we understand, but we are not realizing. And the last, unknown unknowns, is looking at factors of which we don't have knowledge nor awareness. Hector, please. Thank you. The principles of chaos engineering are 5, that are the ones we're going to explain here. And those are the ones in which companies and which other companies can take part by helping to improve them, as it is a living document. Well, as you can see, there are 5, and I'm going to explain the first 2, and then my classmate Hector will explain the rest. Well, the first one is build a hypothesis around steady-state behavior, and I will explain it before, but it's about the concentration of measurements about the system, such as its throughput or the error rates that it may have. And the very real-world events are regarding the change between failures, as hardware issues and other types of events not classified as so, like spiking traffic.
Okay, so I'm going to continue with these principles of chaos engineering. In the third place, we have run experiments in production. And it is because if we have to think in which is the most reliable scenario, we have that it is working with real traffic. Then automate experiments to run continuously. And the reason is that manual experiments, the other ones, lead to a practice that cannot be maintained along time passes. And finally, minimize blast radius. What is that? It refers to that the fallout, the secondary effects from the experiments must be held back, must be contained. Okay. According to the pros and cons, the advantages and disadvantages, on the one hand, if we start with the advantages, we have that anti-fragility and resilience are gained, as it has been explained along the presentation, prevention of significant economic business losses and costs, no loss of client confidence, or help in finding bugs whose solutions may be found easily and faster. On the other hand, with the disadvantages, there are two. Implementation for large-scale systems can cause maybe a higher cost, and failing in the experiment process if the practical steps are not followed as they must be followed. So it could affect the customer in a negative way. But in relation with the disadvantages, if chaos engineering is applied as expected, they are not a real constant. Its use is recommended unless it is preferred to find system weaknesses in a late way without having prevented their appearance. Moreover, this discipline is intended to counteract the 8 logical fallacies of distributed systems. Networks are reliable, secure, and homogeneous, latency is 0, bandwidth is infinite, topology never changes, there is one admin who does not change, and transport cost is 0. These are the 8 logical fallacies, as I have just said. Okay. When is this discipline recommended to be applied? Well, distributed systems are infinitely more complex than monolithic ones, and it makes more difficult to predict all ways they could fail. So we should consider applying this discipline if the applications that bring our business to life are this type of systems, the distributed ones, along with microservice architectures. Actually, nowadays there is a concept called cloud native, which tries to comprise all of that stuff. Continue with which companies practice chaos engineering. We said that all started with Netflix, but at this very moment, Twilio, Netflix, LinkedIn, Facebook, Google, Microsoft, or Amazon are some of the companies that right now are practicing chaos engineering. Industries as banking and finance are getting into this also. An example is the National Australia Bank that moved from physical infrastructure to AWS in 2014. To sum up, chaos engineering is a strong practice which has come to stay and change the way of understanding software in terms of design and engineering. Since the goal is to prevent and counteract the consequences of failures as much as possible, the tests described above should be performed in production with real traffic. This process is tedious and not very pleasant, but in the future it saves time, effort, and lost in services. Okay, so thank you for your attention, and we now look forward to hearing the questions or comments you may have.